Welcome to the OrionX Download. This is a podcast where we discuss and simplify the big ideas in technology that are changing the world. Hello, everyone. Welcome again to the OrionX Download podcast. This is Shaheen Khan, and today I have the pleasure of speaking with Walt McClay, who's the president of Waller Systems. Waller Systems is a company that does electronic product design, development, risk assessment, verification, and they do it for connected smart devices. They've got a lot of skills in sensors and wireless technology. And of course, wireless technologies and 5G communication are big trends that we are tracking at OrionX. So without further ado, we'll go to our conversation. Well, thanks for being here. Please tell us more about you and Waller Systems and how radio communication in general and 5G in particular play a role in everything that you guys do.
Well, thank you for the opportunity to talk today. Waller Systems is a design house. We do electronic design and firmware, so we're designing devices. And we've got really good experience with sensors and wireless communication, so we do IoT and wearable devices. We're always interested in the latest in wireless because wireless is changing all the time. And 5G is currently the latest in wireless. It has a big impact on a lot of areas, as we'll talk about as we go.
We know that 5G is the next generation of mobile, cell phone, radio communication. It comes after 3G and 4G, so we expect it to be better, faster, cheaper. But maybe before we drill down into all that it promises, maybe you can put that whole thing in perspective. Just radio communication from the sensor all the way to the cloud and back. How does all that work?
There's a whole variety of different types of wireless communication because there's a whole bunch of different capabilities and needs. And basically, what you're trading off all the time is the speed that you're sending data, how far you're sending data, and how much power you use.
Uh-huh.
Now, if you've got something that's plugged into the wall, the power isn't such a big deal. But on a cell phone or a wearable device, you got a battery, and it's a big deal. And then the speed is very important. Your cell phone needs to carry voice, and now it needs to carry video. And now with 5G, we're talking about way higher than that. And then there are the devices that may send the temperature once an hour. The data rate is dramatically different. So you've got different types of communication. Bluetooth LE is extremely low power and can send the data 10 or 20 feet reliably to a cell phone, and it sends fairly slow data. And for many applications, that's perfect. If you want to get directly to the internet and you want to have high-speed data, well, 5G is the way to go. You've got a lot of different choices, and that's why you do.
Now, when you go through all of these different protocols, Zigbee, BLE you mentioned, traditional Wi-Fi, and then when you go farther distances with low power WANs or now 5G, I imagine that in a typical deployment, a whole number of these are at play. That even if you go with 5G, maybe the back end is going to be wired or fiber or whatnot.
Oh, yeah. When you go to the internet, once you get to the backbone of the internet, it can go through optical, it can go through wireless, it could go through telephone lines. There's all kinds of different things involved. It's a very complicated infrastructure.
So for the consumers, really, it's about getting to the cell tower. Is that correct?
Yes, pretty much with everything. When I talk about Bluetooth LE or even Wi-Fi, it doesn't go directly to the internet. It doesn't go directly to a cell tower. You have a hotspot. Well, the cell tower is like a hotspot, except it's provided by someone else. It's public, and they're everywhere. You can roam from one to the other. They're almost everywhere. So the ideal situation for many applications is to transmit directly to a cell tower or a hotspot of some kind, and to be able to roam and have them everywhere. Well, 5G and 4G as well do exactly that. But there are some others. There's NB-IoT and LTE-M, which are cellular based, but they're lower power and they're designed for lower data rates.
Uh-huh.
These are complementary to 5G. And they go similar distances. They go many kilometers or many miles.
So let's start with frequency spectrum, because it's hard to talk about 5G without getting to that pretty immediately. And it seems like a lot of what 5G promises are enabled by just that frequency bands that are available.
Exactly. Yeah, we have to talk about some details to make it all clear. So there are three different bands. Two of them are already in use in 4G. There's the band that's below 1 gigahertz and the band that's between 1 gigahertz and 6 gigahertz. Below 1 gigahertz has a long range. They claim up to 20 miles, but I don't know. That's in ideal conditions.
Hmm.
So if you're out in the country and you put up a cell tower and aim it down a freeway, it'll go for a long distance. And then in the 1 to 6 gigahertz, it's pretty good. You're used to seeing it on your cell phone. You often don't know whether you're in the low band or the mid band. And it works pretty well, not quite as far a distance. But what's new in 5G is the millimeter wave. This is above 6 gigahertz. And it's open in an area that goes all the way to 89 gigahertz. Currently, it's primarily in the US in the 20 to 30 gigahertz range. This band has some big advantages. It's new space that's not being used. The lower bands below 6 gigahertz are getting pretty used up.
Hmm.
Also, you can have much higher bandwidth, so therefore much higher data rates. So when they talk about high data rates, they're talking primarily about the millimeter wave band. The downside of the millimeter wave band is it doesn't travel very far. And we'll talk more about that.
And in fact, speaking of that, really none of this matters if it's not available. So what does the coverage look like now, and how do we expect it to change over time? Who's offering what?
Coverage is very dynamic right now. I've got data from November of 2019, which is now quite obsolete. And there's some more recent data. But as of November, the major cities were covered with 5G. And if you take California as an example, 3 of the 4 carriers didn't cover the Bay Area.
Huh.
I think that's changed now. And I don't try to keep track on a month by month basis. So it's being built out very quickly. In the country, however, I think you're going to find the availability is much less. Now, I believe that if you get a phone, pretty much any phone that's 5G, it will work on 4G. So if you buy a 5G phone, you'll still have service. You can have 4G service. You just may not get any benefit from it. So if you pay extra, what have you gotten?
Okay, so now 5G, in addition to cell phones, there's obviously an IoT connection, and it seems like there are classes of services that they categorize. What are those?
This is what's really new about 5G. There are 3 different types of service that are very different. The first one is enhanced mobile broadband, or EMBB. This is the standard cell phone that goes to computers and laptops and iPods and whatever. This is going to give you much higher data rates, up to 2 gigabits per second. Similar kind of communication to what you're used to. The second one is ultra reliable low latency communication, or URLLC. This is a completely new category. Typically, these will be on-premises devices. For example, they're used for a factory.
Within the factory.
You can set up your own cell service and cover your factory and have extremely fast, very low latency, and very reliable communication wireless. But it could also be in a stadium for everybody to use their cell phones. The third one is completely different. Massive machine type communications, MMTC. This is really IoT. Very low data rates. Latency is unimportant, but power is everything. And it's completely different from the others. And the funny thing is that they haven't even finished the standards for massive machine type communications, or IoT. And what's really available today is NB-IoT and LTE-M, which have been built out in 4G cell towers.
I see.
Today, IoT hasn't really changed on 5G.
When we talk about inside the premises, as you mentioned, in a factory, why not just use Wi-Fi? Why do you need to go 5G inside the factory?
Good question. Wi-Fi is also improving, and both Wi-Fi and 5G are using new technology that's providing more devices in an area, lower latency. I'm not aware of the ultra reliable low latency communication being offered from Wi-Fi.
Uh-huh.
So it seems that there's something special there. But yeah, Wi-Fi is definitely a competitor for this.
Right, because sometimes I think just a combination of BLE and Wi-Fi should be good enough for a whole lot of use cases, and then maybe LTE-M to get out there. And if all that works, then why make such a big deal about 5G? But we're going to discuss that.
Yeah.
Okay, so bandwidth. Everybody thinks of 5G immediately as it's just going to be faster data communication. We know it depends on the frequency, but what can people expect to get, and how is that different from geography to geography?
So the bandwidth you get depends entirely on which service you're getting, what frequency band you're in. If you're in the sub 1 gigahertz band, they're repurposing 4G to 5G for that band. You're going to get a modest improvement over what you got now. You may not even notice. You'll get something like 100 megabits going one direction, 50 megabits going the other bits per second. In the 6 gigahertz, 1 to 6 gigahertz band, it's going to be significantly different. You can get up to 400 megabits per second, which is perhaps 4 times what you can get, or 3 times what you can currently get in 4G. Significantly different. But the really big improvement is in the millimeter wave band, where you can get 2 gigabits per second. This is 20 times what you can get in 4G. Huge difference. There's a big issue there, though. The millimeter waves don't pass through buildings. They don't pass through windows. If you put your hand in front of it, you block it. It doesn't go through rain or snow. And the distance that it travels is a small fraction of a mile. So you can only find these in dense urban areas. You're never going to have the millimeter wave, as far as I can tell, in a rural area. And I don't see how it'll even be in suburban areas, because you'll need a cell tower approximately every 100 to 300 meters to get the service. And we know that there's been a problem in putting lots of cell towers into suburban areas.
Already hard to have the ones that you already have there.
Exactly. And making them 10 times more dense or 100 times more dense, I don't see it happening.
Right. And maybe we'll touch on it later, but of course, there's a whole lot of controversy about cell towers in general.
Yes.
Let's move to latency. Now, latency is another promise of 5G. How does that look?
5G offers very low latency, but we've got to talk about the conditions. For some applications, latency is fine already. For voice, and in many applications, even video, if you're just downloading a TV show, 4G works and 5G will work fine. But where latency is really cool is, let's say you're doing an AR or VR application, and when you turn your head, it needs to download the video instantly to show you where you're pointing. A delay of tens of milliseconds is noticeable. So 5G can get you down into the 1 millisecond latency. However, think about how far away the other person is so let's say you're playing a game. If they're on the other side of the country, it takes, 186,000 miles per second. You can calculate what it is.
I think it's about 30, 40 milliseconds across the country.
That you're not going to get 1 millisecond.
You have to come back too.
Yes. When they talk about the latency, they're talking about one direction going just from the transmitter to the receiver. So say it's from your phone to the cell tower. It doesn't count the time coming back. It doesn't count the time going through the internet itself. And every time there's a switch on the internet, you add about a millisecond. So in many applications, you're going to be 20, 30, 40 milliseconds. And in 4G, you've got maybe 50 to 100 milliseconds. So it's better, but maybe not dramatic. Now, if you're in those ultra reliable, low latency applications where it's just on a factory floor and it's traveling 100 meters, then you can get to 1 millisecond latency because the distance is very small and you're not going through the backbone of the internet. So in some applications, you can get it.
I see.
One application would be for remote surgery. Now, if it's across the country, you got a bit of a problem. But if it's not too far, if it's just in a rural area outside the city, you can get a very fast and very reliable connection if you have the high frequency millimeter wave cell tower available in this rural location. I think the hospital would have to set it up just for the application.
So this would be a case where the local hospital has the tower and some remote surgeon is actually doing the surgery because you want him to do it or her to do it.
Yes, there's a shortage of surgeons in the countries, but if you can get somebody in the city to do it, that would be nice.
Okay, so two things come across to me there. One is interactivity, and one is access to some remote expertise or talent or whatever that is compelling.
Yeah, so having that remote is good, but with a surgery, having anything more than a 10 millisecond or so delay you begin to notice that you moved something and it didn't seem to move when you moved it, and it really interferes with your ability to move. If you move your hand and your hand doesn't move when you said to move it, your brain doesn't operate very well with that.
Right. Feels like those movies when the dubbing is not synced up with
That's right.
the.
Yeah.
So the perception is that high.
It's in tens of milliseconds.
Mm,
If you can get to 10 milliseconds, you're fine.
right.
At 50 milliseconds, it's very noticeable.
Interesting.
So it's somewhere in that range.
Interesting. Very good. So we kind of had the similar jump going from 3G to 4G. I remember that. And that really did not seem to be a big deal. Would you paint a picture for us of what's going on the standard side and a summary of what all is being promised?
Okay, that's a big topic.
Yes.
So, first of all, if all you did was use your cell phone to do voice, when you went from 3G to 4G, you didn't notice any change. But there are services that are provided that rely on 4G that have made things very different. The internet on your phone in real time, where prior to 4G you didn't. It has made a big difference, but it happened maybe just a little slowly and people didn't really notice. But some people noticed and it turned into billion-dollar industries. There are startups that are their business is possible because of 4G. 5G is probably going to do the same thing, but what they're promising isn't always available. You're not going to have the millimeter waves in the country, or probably not in suburbia. So those high speeds at low latencies probably aren't going to be available to you there. Even in this dense city, if you're indoors, the only way you can receive it is to have a picocell. You may be familiar with picocells in 4G. They're handheld devices. If you're in a busy area like a trade show, you want to have your own cell tower to guarantee that you can have cellular. So you bring in a picocell. Well, you'll be able to do the same thing with 5G. Now, the antenna has to be outside because the signals don't go into the building. But with that, and if you put one in every room, you can have 5G indoors in the millimeter wave band. And right now, these are pretty expensive. They may be in the $1,000 range, but they'll come down. There are some things that have to be done, and I suspect that a lot of this will happen, and we'll start to see 5G in those places in the dense urban areas. The millimeter wave 5G that gives you up to 2 gigabits per second. They claim higher, but I haven't seen higher yet.
You're saying that it's going to be hard to get everything that 5G offers at the same time.
Yeah. For example, there was I've forgotten which magazine did this, but they went out and did some studies. They got some measurements of speed. And I think it was with AT&T. They had AT&T take them to a place where they could get 1.8 gigabits per second. But they pointed out that when they were more than 100 or 300 feet away, so more than 100 meters, they didn't really get the same performance. So that means you got to have a cell tower within about 100 meters or less to get this. And you can't be indoors. You can't be in your car. It can't be snowing or raining. So this is very limited for right now.
Let's talk about use cases. You already mentioned augmented reality, virtual reality. What else seems like a reasonable, legit use case?
Well, for the ultra reliable, low latency, there's some fascinating new use cases. I mentioned a few of them, like remote surgery, use in a factory. Another one is on power distribution. One use case is to send the signal down the power line for many miles, and it's just along the power line. And again, this is on premise. This is not available to cell phone users. This is available just to the utility, but it will allow them to monitor and control the power lines better than they do now. This is a big deal. It's all transparent to most people, but it's a big deal. Another one that's more visible is in automobiles, where 5G will go 2 kilometers down the road. It will be picked up by the car. The car will be able to communicate with the road, with other cars. You'll be able to see around the corner. The lights will be controlled to improve the flow of traffic. This is a smart city application.
Uh-huh.
This could be a really big deal, particularly with self-driving cars. And again, that's not going to be picked up by your cell phone. That's going to be picked up by your car. So there are some very interesting things that are coming up. Another one would be if you get a large group of people together in a stadium or an entertainment facility, you can have the millimeter wave band in that facility, and everybody can have communications at very high speeds and very low latencies through their cell phones and other devices. And who knows what kind of new interesting things will happen probably in the realm of entertainment.
I see.
But entertainment is a really big area, and so I expect a lot to happen in that area.
You're right. If you're sitting in a stadium and you can just watch it replay on your own phone from 5 different angles, that's new.
That could happen. But what will be most interesting will be the things we can't even think of.
Right. All right. Now, coming back to the end to end part of it, what do you need in an end to end way to have a real 5G infrastructure in place? And where I'm going with this is maybe a little bit a nod to the whole geopolitical aspect of this is who makes these devices, starting from the sensor all the way up. What is really interesting to me is the kind of vendors that are in this market that some of our audience may not have heard of, besides the usual well known players.
Okay. There's a huge infrastructure that's providing 5G. You start out with the network suppliers. Everybody's heard of AT&T, Verizon, T-Mobile, Sprint. There's the phone manufacturers, Motorola, Apple, LG, and many others. And then there's equipment manufacturers. They make equipment that's used, for example, in the cell towers, Ericsson, Nokia, and many others. And then there's the companies making the semiconductors that go into the equipment. Qualcomm, Intel, Marvell, ARM, AMD, Xilinx, and many others. And then there's others beyond that. You could get into all kinds of things.
Sensors.
Yeah, sensors, for example, services.
Hmm.
There are companies, all they make is IP. They license technology. It may go into all of these things. So there are hundreds or thousands of companies that are involved in 5G.
I'm just going to make a comment, and that may very well be why your business is so critical, is that if you're just the average manufacturer and you're trying to get into the IoT business, just making sense of all of that requires folks like your teams who really know what they're talking about in this area.
Yeah, I guess so. If you want to use a phone, you go to AT&T, Verizon, T-Mobile, Sprint, and they've worked with all these other companies to provide you the service. So it's very simple. We do the same sort of thing. You want a device that connects in a certain way, we can give you the advice on what technology. It may be 5G, and maybe it's not. One's going to work best for your application.
A few other things we haven't talked about. One of them really is device density. And you keep reading that the spec for 5G is 1 million devices per square kilometer. Is that real? And wasn't that kind of solved already with just a whole bunch of Wi-Fi hotspots in one place?
Wi-Fi isn't going to get you that kind of density. There'd be an awful lot of hotspots interfering with each other. So they do claim 1 million per square kilometer. Now, because some of the claims aren't entirely real, I take it with a grain of salt, but they have done some things that do make this possible. For example, the antennas are directional. So you've got all the bandwidth in one very narrow direction, and then just a few degrees over, you've got all the bandwidth again in a very narrow direction. Well, that dramatically increases the number of devices that you can have. They also have not only split up the bandwidth by time, they split it up by frequency. So they've done a lot of things to increase the amount of devices that you can have. Now, even if it's a lot less than 1 million per square kilometer, for right now, what that means is when you are traveling on 5G, you should not see the drops that you see with 4G.
I see. Because there's just enough capacity and there are so many different ways to get to the tower, right?
Yeah.
I see.
Now, if you move out of an area that has 5G, you might see a drop.
So you'll get right back. Right. But back to the whole stadium thing. How are they solving it now then without 5G?
You can get 4G in a stadium. They have to have a lot of cell towers or cellular sites to handle the service. You'll be able to do it with a fewer number of sites with 5G. But what you can't do now is you can't get to 2 gigabits per second speed and the low latency. And in something like a stadium, that's what's going to make a big difference.
Right. Okay, along those lines where is the device? The whole global positioning and location tracking and the precision with which you can do that. And 5G promises a lot in that area too.
That's right. So location of a device is a big deal. There's all kinds of capabilities and services that require location. And then it's a big deal that you may not want people to know where you are. You can turn it off. So with 5G, they claim they'll be able to locate you within about a meter. Now, whether it's an absolute meter or just a meter this way or that, relative, a meter is pretty precise. But if you think about it, you already know which direction someone is because you've got this directional antenna. On top of that, they're measuring signal strength, which gives you a pretty good indication, though signal strength can change rapidly without a change in location. And then there's a certain amount of triangulation, and now we're going beyond what I know. But instead of just knowing that you're within a cell tower, which is, within a mile or two, they're going to know very close where you are, perhaps better than with GPS.
Interesting, interesting. And I think it's also a reminder. I remember in the early days of cell phones when they didn't have GPS, they would have to really rely on whatever towers were around you and try to figure out where you might be with some level of precision, but far from what GPS gives you. So this thing is going to get close to GPS or better.
Perhaps better.
That's impressive.
Now, depending upon which band you're using, it works indoors. It may work indoors.
Mm.
And it may be able to tell you which floor you're on, which
Ah.
is also very important.
Or which aisle of the
Right
supermarket.
now, if you've got an emergency and all they know is that you've got a phone in a certain cell location and it's in the city, they don't know which building you're in or which floor you're on. You could be dead before they find you. Now they're going to know exactly where you are. So this could be a big deal.
Ah, so this is the stuff that you used to see in movies, and they now have it for real.
Yeah.
Interesting. Let's talk about power. You mentioned that a big part of this is how far you go and how much data and how much power.
Yeah. So one of the things that 5G advertises is low power. Well, you can't get everything for free.
Mm-hmm.
When you're going at really high speed and long distances, it's not low power. The IoT service will be low power, but that depends entirely on how much data you're sending and how often you're using it. So the 5G itself is not really low power. In fact, when you're in the millimeter wave band, you're using more power. One issue they've got with the 5G cell towers is they use about 3 times as much power as 4G. So they're not so green. So there's some things people complain about.
Right, right. I want to mention that we were both on a meetup recently that talked about power harvesting. And I just wanted to mention the concept to our listeners just so they know that is going on as well. If you might speak to that a little bit.
Yeah, energy harvesting is fascinating and it's growing. It uses sources like temperature differences, solar power, motion, and many other things. RF energy, for example. It pulls that out of the air or out of the environment and converts it to electrical energy. It's a great idea to reduce the need for batteries. The biggest limitation in energy harvesting is that it generates generally microwatts of power. Using solar power, you can get more, but you might need a pretty big solar cell. So you're not going to see energy harvesting replacing the battery or even recharging the battery on your cell phone unless you're barely ever using it.
But it's definitely an interesting addition and it's free.
For IoT, it's a real interesting space. If your device doesn't send very much data, if the sensor doesn't use much power, energy harvesting is very interesting.
Right. I always imagine a vending machine in the middle of the desert or something.
Yeah. A vending machine in the desert can have a pretty good sized solar cell. So, yeah, it can easily run on energy harvesting.
Okay, the most important thing we haven't talked about is cost. And I know that as an engineering shop, that's exactly what drives all the trade-offs that one must do in a design. So let's talk about that and how that limits or opens up new markets.
Well, so if you look at 5G, I haven't priced out phones, but I'm sure you pay a premium to get 5G. There's more technology. The actual cost to the manufacturer is a bit higher. And I'm sure right now they're making a higher margin, so it's significantly more. But take a look at something like IoT. I mentioned that, in fact, IoT on 5G, they're not really providing anything that wasn't already here. But the cost for doing IoT direct to the internet has been dropping. A couple of years ago, it was several dollars per month to have that service. It's gotten down to well below $1 a month, depending upon the amount of data. But if you're sending thousands of bytes per month, that's trivial. So it's very low cost. As the price goes down, new uses come up. For example, wearable devices can now communicate directly to the internet, where 1 or 2 years ago, the coverage wasn't there. The only way to do it was you use Bluetooth or Wi-Fi going to a phone, and the phone would go to the internet.
Right.
Well, having a wearable device that requires a phone is often inconvenient. Now it can communicate directly.
Excellent. Very, very fascinating. Well, 5G continues to be a big mega trend of our times and really important in many ways. Before we close, maybe we can touch a little bit on the healthcare concerns of 5G. And we mentioned it earlier in the program. There is a lot of controversy, there's a lot of misinformation. What is your perspective on all of that?
Well, there are people who are concerned about the millimeter wave frequencies. They haven't been well studied for their effects on humans. If you remember a number of years back, the same issue was discussed about the lower frequency bands in any cellular phone. And in fact, there are requirements to minimize the amount of radiation absorbed by the head when you're using a cell phone. And there have been many, many, many studies, some of them paid for by people with an interest. So some of the studies are suspect. And there's probably not a big deal, but there's still uncertainty, even in the lower bands. And I think in the higher bands, the same thing's going to happen. It's a $1 trillion industry where people want the results to come out a certain way. So there are going to be many studies that are slightly biased, and you may not even know that they're slightly biased. So we'll never get this controversy to go away completely. There's concern, and I think they'll continue to be concerned for some time.
Yes, in agreement with you. I just don't think there's enough data, and the data that is there seems just insufficient. That's hopefully something that the industry will address.
Well, the industry may try to address it, but if the industry backs a study, that study is suspect.
That's right. Well, yeah. I don't know if I'll include this, but I'll share this quote from one of the VCs that said, "No conflict, no interest." Well, very good. Thank you, Walt. Thank you for making the time and this very informative session. I look forward to staying in touch and track this thing as it progresses.
I've enjoyed the opportunity to talk, and it's a topic I enjoy talking about.
Perfect. Thank you. That was great. I want to thank Walt McClay again for being with us and taking us through this very, very interesting conversation. Before we end, I want to summarize what all 5G promises. It promises speed, low latency, high density in terms of number of devices per square kilometer, better precision in terms of positioning and location tracking, low power, high coverage, and a whole lot of back-end efficiencies, including the three class of services that we talked about. On the other hand, you're not going to get all of the above at the same time, or if you do, it's going to be a very special situation. And then there are still lingering questions about its health effects, which in my opinion is entirely because there's just not enough data, there's not enough testing, and not enough data to convince everybody, which is unfortunate because there's also a lot of misinformation that can get in the way of the adoption of the technology unjustifiably. So with that, look forward to the next one. Thank you for being here. Bye-bye.